Okay, so what I want to talk about today is the factors that may contribute to scientific progress or be detrimental to scientific progress. So I want to look at two writers. One of them is a historian of science named Thomas Kuhn, and he's going to give us what he's calling basically this kind of theory, this account of how science changes. He's reluctant to use the word scientific progress, but science does change, specifically in a given discipline. So I want to give you this this account of how science progresses, how science changes over time. And then we'll talk about a sociologist of science whose name is Robert Merton, who basically is going to talk about what is it, we have to understand in the real world, science is not this sort of idealistic enterprise. In the real world, science is constituted of a bunch of different individuals with a bunch of aims and desires and ambitions and egos. So what is it about the internal workings of science that may contribute to the advancement of good science, what he calls pure scientific sentiment? And what is it about the dynamics and the characteristics that are internal to science that may actually lead to bad science? Okay, and then he also looks at, let's say, science also does not operate in a vacuum. It operates in a broader societal environment, and so it has to contend with and develop relationships with other institutions and other organizations. Sometimes these relationships are beneficial, and sometimes they're regrettable. Sometimes they are constructive. And came in here. Max, need to mute yourself.
Yeah.
Okay, thank you. So science, so for instance, science is operating in a world alongside politics, ethical considerations, economic interests, religious doctrines. So how does science sort of find its place? And how does it collaborate sometimes beneficially with other institutions? Sometimes it has to necessarily work with other institutions, especially if it's seeking, authorization, or if it's seeking financing and grants and so on. Basically, the point is, science does not operate in a vacuum. It's made up of people with different interests and motivations. People that operate within science and people that operate outside of science, but nonetheless have an influence on what science gets done and what science is permitted and not permitted. So some of these relationships may be collaborative and constructive, and some of these relationships may be detrimental and destructive. Okay, sometimes institutions and organizations that are outside of science may try to even hijack science, try to utilize science or coerce science into basically serving its agenda. And sometimes they just want to throw a stick in the wheels of science. Okay, so that's what Robert Merton is going to talk about. So why are we talking about this? We're talking about this because we spoke about, especially around the midterm, what is a good scientific theory? How do we evaluate scientific theories? How do we distinguish science from pseudoscience? How does sort of the scientific process, how does the scientific method generally work? And we were talking about it sort of very idealistically. Okay, so now we have to sort of bring it back and understand how science actually operates in the real world. So that's basically what we're talking about. So let's start with Thomas Kuhn. Thomas Kuhn writes a very influential book, a very important book, and a very well-written and interesting book called The Structure of Scientific Revolution. And basically what he's saying, there's two key words here they have to understand. First key word is this word of paradigm. Science, any scientific discipline is always operating in a paradigm. A paradigm is, what is the basic assumption of what we regard as true? What is the basic foundation? What is our basic starting point that we all sort of agree upon? That's a key word, paradigm. And the other key word is an anomaly. An anomaly is something that is discovered, which doesn't fit the prevailing ideas of what makes sense, the foundation of the science. That's a little bit abstract. Let's try to get into it. Let me try to give you an example. So the first example, and the obvious example that we've returned to several times, is, for instance, one paradigm, let's say prior to the Renaissance and prior to Copernicus and Galileo, the fundamental paradigm, especially from an astronomical point of view, was the world was at the center of existence. The world is round and the world is at the center of existence. Then there's a paradigm shift. We switched to a fundamentally different theory of reality. And this theory is so essential that it's sort of foundational, that everything that is done and everything, all scientific inquiry that happens afterwards is done with reference or on the basis of that basic assumption of that foundation. Okay. So let's say prior to the Renaissance, the fundamental paradigm is, the fundamental understanding is that the world is round and it's at the center of existence. After the Renaissance, we have a different model, a different paradigm, a different fundamental theory, which is the world is round and it's nowhere special. Okay, that there are potentially many planets that have characteristics like ours. There are many solar systems. There are many potential, suns and stars with solar systems, and we are just in one particular galaxy, and there are many galaxies. Okay, so we're nowhere in particular in the larger scale of existence. What else I want to add is you can even go back further. You can say, let's say, if you were living 10,000 years ago, the basic idea of your civilization, 5,000 years ago, it may have been that the world is flat, and that was the prevailing paradigm. That was the basic. The paradigm is, what are sort of the basic assumed ideas of reality, that everything that is understood relative to that, is understood based on that. Yeah. So he says we have to understand what a paradigm is, because a paradigm determines what the rules are. Okay, it determines and establishes the boundaries, and it tells us how to behave inside of those boundaries. Furthermore, inside of a scientific discipline, as I said, a paradigm gives us a sort of a vision of what is the basic reality that we are all agreeing upon. And so it is, this is a good way to put it, a paradigm is a fundamental image of the subject matter within a science, and it serves to define what could be studied, what should be studied, what kinds of questions can be asked, and how we are supposed to obtain answers to those questions, and how are we supposed to interpret answers to those questions. Okay. So let me also say this is, for instance, if you say, okay, I'm interested in science and I'm going to do a PhD, the general understanding is that when you do a PhD, you are asking a question which has never been asked before. You are in some sense covering new terrain. You are you are addressing something which has not been addressed or answered. That is true to some extent, but we have to nuance that, because what Thomas Kuhn is saying is that you cannot just come up with a random question that is interesting to you. The question that you are answering, albeit unanswered, must be a question that fits into and relates to the ongoing dialogue. There's an ongoing discussion within any given scientific domain, any given scientific field. So let me try to give you this example. So that is to say, you're asking and researching a new question, but it's a new question which is entailed by and connected to that fundamental paradigm, which is there prior to you, and which is in some sense more dominant and more important than your specific question. That's generally 99% of science is what he calls normal science. Most of what scientists are doing, let's say 99% of the time, is they're doing what he's calling normal science, which is they are asking questions which are implied by the basic paradigm. Now, let me try to give you an example of that. Suppose you are interested in psychology and you want to do, graduate research in psychology. You want to do a PhD in psychology. You cannot just sort of come up with a question, albeit unanswered, out of the blue. Your question, your research has to fall back on the ongoing flow of discussion. Okay, it has to be part of the ongoing debates which are implied by the fundamental paradigm. So let me try to be a little bit more concrete here. If you say, for instance, oh, I want to come up with a theory of personality based on, dream psychology, based on Freudian psychoanalysis, they're going to say, no, sorry, you're not going to do that research here. You're not going to do that research in this department, because that's not the basic paradigm that we're operating. Freud is done, okay? In other words, if you wanted to consider that question maybe 80 years ago, maybe you would have had a platform, okay? And maybe we would have recognized the legitimacy of that question. But that's not like, no, in other words, we're not going back there. It's an obsolete, that is a question that is based on a sort of an obsolete idea. And suppose you are really cutting edge. Suppose you really come up with something, let's say, special, Suppose you are going to come up with, let's say, some parapsychology idea of remote viewing or, telepathy or something like that. And you have a theoretical account of telepathy or remote viewing. They're going to say, no, sorry, that does not fit into our basic assumptions. That's not considered a reasonable question. You might be a genius and you might be right, and you might in 100 years from now be vindicated, and you might be able to say, look, I knew it all along and I was right, and this department rejected me. Doesn't matter. Okay, you always have to, the research is always conducted based on the prevailing understanding of what is generally true. So what would that be in psychology today? It's no longer Freudian psychology and psychoanalysis. It's no longer, humanistic psychology. Everything that is done in psychology today has to be done within the framework of neurocognitivism. Basically looking at the brain and how the brain relates to different aspects of cognition and intelligence. And that's very interesting. There are an abundance, if not infinite, questions that you can ask within that framework. But it has to be within the framework. Okay, doesn't matter how smart you are, how much of a genius you are, how exciting your theory is. It always operates within the framework. But the question is, when does the framework change? When do we fundamentally have a fundamental shift in the basic framework? Okay, and that's what he calls a scientific revolution. So I'll try to give you an analogy. It would be better if I could sort of draw this. But you can imagine, let's say, a building. Okay, let's say building A. Building A is, by analogy, a scientific domain, a scientific discipline that is built on a foundation. Okay, it's built on, let's say, paradigm A. And what most of science constitutes is basically filling in all the rooms and discovering all of the contents of each of the rooms that is structured and built upon this foundation. That is what he calls normal science. So you are asking and answering questions that are implied by the paradigm. But while you are doing this research, over the course of the years and the decades and the centuries, little anomalies start to appear, okay? What is an anomaly? It's something that doesn't fit. It's something that we cannot even begin to make sense of based on the paradigm, okay? It's a discrepancy. It's something that doesn't make sense. It doesn't fit, okay? An anomaly is something that deviates from what is standard, normal, or expected. So it's a little crack that appears, okay? Little cracks start to appear, or, in the joints and in the ceiling. So you have two options. Normally what happens is you sort of either you ignore it, say, I'm just going to ignore it, or, you do a little bit of ad hoc work. You put a little bit of duct tape, put a little bit of plaster, you paint it, you cover it up. Okay. In other words, you say the theory is generally good. These are little cracks that are starting to appear, but they're no big deal. Generally, the theory is more functional than it is dysfunctional. Okay. But as normal science progresses, more and more cracks start to appear, and the cracks start to get bigger and bigger and bigger. And at one point, what the cracks start to, it's like sort of the whole thing that we talked about with ad hocs. A little bit of ad hoc is okay. A little bit of patchwork is okay. It's useful, it's functional. But once you start to have a car that has more duct tape than actual car, then it's time to change car. If you're spending more money on duct tape than it would cost you to finance a new car, then it doesn't make sense. You're dealing with you're starting to become, you're entering the realm of sort of irrationality. So at one point, what the cracks start to imply is that there's a fundamental problem. There is a crack in the foundation. Okay, it's major. And then there is a sort of question that has to be asked, which is, do we abandon ship, or do we basically drown with the ship? And that's what he calls a scientific revolution. Now we're switching from fundamental theory A to a new theory B. And there may be different competing theories, okay? It's not that there's just kind of one theory and it's obviously better and so on. But you're switching from paradigm A to paradigm B. And now let's discuss the dynamics there. He's going to say, there's sort of really two things I want to say. Is how does this transition take place? Sometimes he says it's violent. Sometimes it's smooth, but sometimes it's violent. And sometimes it's not even scientific, it's political. Okay, so I'll give you an example of that. But let me start by saying, within the scientific field, he says, generally speaking, it's the older people who wields the power. It becomes a kind of a power struggle. Who wields the power in the department is the older people that have been there for 30 years, 40 years, 50 years, and they have built their career, and their reputation is built upon the old paradigm. Okay, and so it's very hard for them, based on their ego, to sort of let that go. They want to hold on to it. Some people are better. They're I guess more humble or better at adapting, that they're willing to jump ship easily. They're better at it. Okay, but some people have to basically sink with their ship. Okay, and I'm not sure if I think he quotes Max Planck that basically says at one point, there's nothing that you can do for these old timers. They're set in their ways, and you basically just have to wait for them to die, like literally wait for them to die. And then the new scientists are younger. They have less affiliation with the old theory. They're more flexible and willing to entertain the new theory. And so it's much easier at that point to switch the power over and say, this is our new basic understanding. Okay, paradigm B. And hopefully paradigm B is more fruitful. It's better than paradigm A. That is to say, ideally, paradigm B answers everything that paradigm A answers, plus some. It doesn't have the anomalies. It also addresses the anomalies that were present for paradigm A. So just two simple examples of that. When we switch, let's say, from Newtonian classical mechanics to Einsteinian relativity, Einsteinian mechanics, that transition was fairly smooth. Okay, it happened sort of smoothly, but it's not always smooth. And again, going back to the example of the story of Galileo and the struggle to sort of try to override and undermine the prevailing paradigm of the time of the geocentric model that came from Ptolemy in ancient Greece and Aristotle, that was actually violent. Like, people actually died. People were burnt at the stake. People were decapitated. Galileo was put under house arrest. So it becomes, in other words, it gets a little bit crazy, because it's not even about winning a battle through scientific argumentation. It becomes political. And in this case, maybe why? Because the theory was there for so long, and it was so deeply rooted in the culture and in the ideologies and in the religion, that it became dogma. That to sort of challenge it was to, in some sense, challenge the legitimacy and the power of the prevailing authorities. So that shift can be quite violent. And now here he's talking about how this change occurs within science. But you can also see this sort of model that he's describing of basic ideas, this shift in basic ideas occurring in other societal issues, political issues. There are culture wars being fought. And then, whoever wins the culture war, it is their ideas, it is their definitions that become the prevalent definition. And then you object to that definition after the fact at your own peril. What else did I want to say with regards to that? So he's giving us a sort of a theory of scientific, I would call it scientific progress. He doesn't use that word, okay? But he is challenging some sort of older ideas of how science progresses. So let me just read it, okay? Kuhn challenges the then prevailing view of progress in normal science, this idea that normal science is a progression through accumulation of accepted facts. So that would be a sort of simplistic idea of scientific progress, is that science progresses just by sort of vacuuming up and gradually accumulating, like a collection, this repertoire of facts. So, we have like 10 facts, then we have 100, and then we have 10,000, and it's good because we're getting more facts. But that sort of seems to disconnect it seems as though there's sort of these facts are sort of independent of each other, like you just sort of find them on the beach. I got this fact here and I got this fact here, and the more facts I get, the more I know. But it's more complicated than that. Okay, that there's always the facts are always somehow related to and reaffirming a basic idea. There's always a sort of a worldview there. So he says that's not quite what scientific progress is this accumulation of facts, nor is it this idea that okay, let us sort of go down this road, and then I realize that I've gone down the road, but I've actually gone in the right direction, in the wrong direction, so I have to do a U-turn and come back. Doing a U-turn and coming back on, retracing my steps, even though I'm sort of retrograde, I'm going backwards. In some sense, I'm also moving forward because I'm correcting an error that I've made. But it's even more than that. Okay. So Kuhn argues for an episodic model in which periods of such conceptual continuity in normal science were interrupted by periods of revolutionary science. The discovery of anomalies during revolutions in science lead to new paradigms. New paradigms then ask new questions of old data, move beyond the mere puzzle solving of the previous paradigm. They change the rules of the game and the map directing new research. So it's like a new map, okay? It's like a new sense of reality in a way. It's sort of like when Christopher Columbus discovered North America, and he thought that he had, landed in India, so he called the natives Indians, and then all of a sudden we have to basically redraw the map of the world. That is basically what it's like when we have a fundamental paradigm shift, even in the sciences. And probably the best way to explain it, the best analogy, it's not actually an analogy because it's true, is he says, you know that a scientific paradigm has occurred when the textbooks become obsolete. So let me sort of describe that. So let's say prior to the Renaissance, if you were studying astronomy in the 13th century and you picked up a book on astronomy written in the 8th century, that 8th century textbook would still be relevant to you and would still be informative of the prevailing theories if you were studying it in the 13th century. But if you have a textbook from the 13th century on astronomy and you are reading it in the 18th century, that textbook is obsolete. In other words, those theories are fundamentally outdated. That he says, when a scientific revolution occurs, you might as well throw the textbooks out. The old textbooks are rendered obsolete, okay? That's different from sort of the textbook planned obsolescence that we have. That's not the same thing. It's not like, oh, if I have a physics textbook and my teacher wants me to buy, the 10th edition of the physics textbook, but my friend has the 8th edition, oh, it's not going to work. No, that is going to work because that's just basically, a marketing scam to sell more textbooks. That's not the same. That's planned obsolescence, not real obsolescence, because the theories in the 10th edition are basically the same theories. The theories haven't changed. Just how they rearranged the problems in the textbook. So that they can basically force you to buy a new textbook. But the theories are basically the same. What he's talking about is the textbook is so old that the theories themselves, the basic theories, are not even the same. And consider what a textbook is. A textbook is, in some sense, the teaching of the fundamental theory. So when the basic theory is out of date and no longer applies, that textbook is basically useless. You know what I mean? It's nice as basically a collector's item, or it's nice to study to see how science has changed. But if you want to understand the current science, studying an out-of-date textbook is not going to help you. Okay, so it's truly obsolete. It's not sort of marketing scam, planned obsolescence of trying to get you to buy a $100 textbook every year. Any questions, comments? No? Okay, so let's proceed. If you have any questions, comments, just cut me off. So now let's look at Robert Merton. Robert Merton is a sociologist of science. And what he's basically saying is the ideal scientist has what he's calling pure scientific sentiment. Pure scientific, in other words, the scientist is the pure scientist has this sort of pure scientific sentiment, is motivated by nothing other than a desire to know the truth, is motivated by nothing other than curiosity. The thing is that science becomes more complex, and he admits that. The cost of science also goes up. So who's going to pay the bill of the cost of science? And so to pay the bill of science, scientists have to, in some sense regrettably, and some sense positively, align themselves with non-scientific players, non-scientific agents that may then, want to have their sort of way with science. So he says that can potentially compromise this desire of knowing just for the sake of knowing. I'm not trying to know anything because I want any practical value or I want any power or, I just want to know for the sake of knowing. So just to put this into context, as let's say, we talked about Galileo. Galileo was able to do cutting edge physics, cutting edge astronomy from his backyard with a homemade telescope. You can't do cutting edge astronomy from your backyard with a homemade telescope. If you want to do cutting edge astronomy, you have to know how to write grants and you have to know how to write proposals and you have to get funding. So there's all of these now additional things that are necessitated by the scientists in the scientific community. You have to be able to write a grant so that you can, with your project, if your project is accepted, they're going to give you, let's say, 2 weekends at the observatory on Momagantic, run by Sherbrooke University, so you can actually do your research. And you better hope that it's not a cloudy night so that you can actually do your research. But that is to say, you need to build sort of a network. You need to know how to write a grant. You need to know how to secure financing and funding for your research. And that is a function of how science has complexified over time. And he says there are many institutions that try to either hijack or derail or sabotage science or use it for their own interests. And he names 3. Okay, and we'll try to give some examples of these. Try to think of some examples of when religious doctrines try to impede or hijack what we might call pure scientific sentiment. Try to think of some examples of when economic utility try to impede or hijack or even potentially derail pure scientific sentiment. And think about some examples when political appropriateness tries to basically derail or hijack good science. So he says, basically, the more science becomes dependent on, in some sense, necessarily so, the more science becomes dependent on external institutions and agencies, institutional agencies, the more its place in society becomes increasingly uncertain. Because now science has to align itself with other players. And science now has to, in order to do science, has to align itself with it has to potentially serve another master other than its own, drive towards curiosity. So one example that he gives, and again, I'm encouraging you, if you guys can think of other examples, let me know. But one specific example that he gives of political appropriateness is he gives the examples of what happened to the quality of science in Germany prior to and after the rise of the Nazis. And he says, German science, especially sort of, the pure and applied sciences, physics, chemistry, in Germany was basically the gold standard. It was the gold standard prior to the rise of, Nazi power. And then the Nazis, came into power and they gradually infiltrated the universities and they changed the mandate. They changed the fundamental direction of what was going to be done, what was going to be financed, what was considered orthodox and not orthodox. And Robert Merton says that the quality of science that came out of universities immediately following the rise of Nazi power was sort of crippling. It was detrimental. What else do I want to say here? Let me see. PowerPoint is. Anybody else have any other examples? So we can think, let's say, religious appropriateness. Can we think of ways in which religion has, over the course of the years and even contemporarily speaking, thrown a stick in the wheels of science? Again, obviously going back to the story of Galileo, I think Galileo would be an example of that. The facts don't matter if your facts do not align with the religious authoritative dogma. So here we have religion throwing a stick in the wheels of Galileo. Don't do your research. Do not speak about the Copernican hypothesis. And I like to entertain this idea. Suppose Galileo was not under house arrest, then maybe Galileo would have gotten around to figuring out at least some of what Newton eventually got around to figuring out. And so Newton would have gotten a head start. Then Newton may have eventually gotten around to figuring out a little bit of what Einstein eventually figured out. So Einstein would have had a head start. So maybe we were, in some sense, in throwing a stick in the wheels of Galileo, there is sort of this butterfly effect that we are now maybe set back 100 years technologically as a result of these, again, institutions that try to derail scientific progress that we all seemingly stand to benefit from. Okay, so I think it is impactful and there are consequences. That goes back to ethics of belief. Again, there are consequences to false beliefs. Another example would be, let's say, during the Crusades and all that stuff, religious wars, the burning down of the Library of Alexandria, presumably done out of, this idea of religious heresy and orthodoxy. So there we go. We have a whole repertoire, probably the greatest repertoire of knowledge in the world at the time was burned down because it didn't, match some worldview. Let's see here, what else we have. So even, let's say, another example would be, let's say, in the United States, where religion has a very strong hold and seems to be having an increasing hold. That will, in some sense, directly or indirectly dictate what is permissible, what scientists should receive funding, which scientists should not receive funding, which programs should which research proposals will receive grants and which won't. So in other words, there's a lot of money that goes into research and development of the latest drones to drop bombs. Now they're talking about autonomous killing robots. There's a lot of research that goes into how to deliver a nuclear warhead. But things, let's say, researching stem cells, that is sort of prohibited because there is either a direct or implicit sort of religious resistance to that. Even, let's say, when it comes to, let's say, policy which ignores scientific data or scientific advice, you might say, let's say, the banning of abortion on religious grounds amounts to basically a denial of the statistics of how many women are going to die or get injured as a result of basically, like, homemade abortions or back alley abortions. No, we just ignore that because we are sort of pro-life, but when that occurs, those statistics do not factor in. So you see that. Another example, and this one hurts me particularly, is, for instance, the policy that obviously comes through the channels of religion that ends up being part of the school curriculum in some places, that creationism should be taught alongside and as an equivalent theory to, as a competing theory to evolutionary theory, is problematic. Okay, is undermining the quality of scientific education. There's no legitimate basis for equating those two theories. Okay, and I think that has something to say with what he's going to say later on, which is as science progresses and as it gets more complex, it does open up the door for all kinds of pseudoscience. Paradoxically, and I'm jumping ahead of myself a little bit, but what he's going to say is, paradoxically, science, through its success, opens up a gap between what the scientist knows and what the average person knows. And that gap which opens up ends up being a very, very fertile terrain for pseudoscience. So science becomes, in some sense, a victim of its own success. It progresses faster than it can convey that information to an ordinary person. So it creates a fertile terrain for pseudoscience. Why am I saying that in this context? Is because there's something to be said about scientific education. There's something to be said about being able to convey scientific theories in a way that is approximately intelligible for ordinary people. And when you are actually undermining scientific education because of combining subtly it with religious education, which are two different languages, you are actually undermining, you're actually furthering that problem. You're opening up the door for, let's say, magical pseudoscientific thinking, because you're actually undermining the population's direct access to scientific education. Okay. This is a sort of a kind of a combination problem of the attitudes and dispositions of scientists, their ego, their desire for reputation, but in the broader context of, the market and being first to publish and so on. So there was this interview that is a while back, okay? But basically this author was saying how, especially in biomedical research, there is such a pressure on the researchers to basically this idea of publish or perish. You have to be relevant, okay? You have to be generating meaningful, interesting data. And he says all of these pressures not necessarily lead to, but definitely augment the probability of bad science. Okay, it may sort of infringe on careful, rational, critical thinking that is required in science, and you may have even, it creates a sort of an incentive structure where you might even have some scientists that are willing to commit fraud, skew their data deliberately in order to come to a conclusion that so that they can be, let's say, the first one to claim to have discovered this thing, and so on. So that can also be problematic. What's he saying here? What's he saying is, should I read it? Maybe I shouldn't read it. But basically what he's saying is what I said. He says, as science becomes more complicated and becomes more sophisticated, even in terms of the instrumentation, he says, with an increasing degree of complexity of scientific research, a long and rigorous training program is necessary to test or to even understand new scientific findings. So basically it's like from the ordinary person, the layman, the layman, when we talk about relativity or quanta, it might as well be magic. We understand that science works because we have science presented to us in the form of technology. It's not like, oh, scientists are up to something big, and just trust them. But there's nothing that we can show you yet. It's kind of like a secret, and we're still in the dark ages. No, we have progressed, because what we see of science is the technological byproduct of science. But all of this is like magic. We don't really know how this Zoom call works. I don't know how my cell phone works. We don't even know, how light bulbs work. A lot of us don't even know how electricity works. A lot of us don't even know the voltage that's running through the cables in our own walls. So this is what, as I said, he says, science is bizarre. And because of this, he says the popularity of new science basically opens up the door and it becomes indistinguishable from basically the esoteric. Science, from the perspective of the ordinary person, is like magic. Okay, and actually, if you want to do a magic show for kids, you're getting a scientist there, and he's going to be using science because we can't understand it. But let me just jump ahead here to this point. He says this becomes, as I said, very fertile ground for pseudoscience. Partly as a result of scientific advancement, therefore, the population at large has become ripe for new mysticisms, clothed in apparently scientific jargon. So it's very easy for somebody to then to come in like a con artist and to present themselves as scientific, wear a lab coat, use scientific sounding jargon, and present themselves, under the ethos, under the credibility of being scientific. And from the layperson is at that point unable to distinguish. Because it appears to, from their perspective, to be the same. You see that with a lot of pseudoscience and conspiracies that we've analyzed. Is this whole proof by verbosity? Is people sound like they know what they're talking about. They use, but he's using big words, so it sounds kind of sensational, exciting. So he says this promotes the success of propaganda generally. The borrowed authority of science becomes a powerful prestige symbol for unscientific doctrines. Okay, says as I said, science becomes in some sense a victim of its own success. It opens up not only a sense of the mysterious and the imagination, but it also creates a gap that then people can slip in between the actual scientists and people that don't understand what science is. So just a few more examples here of, let's say, economic utility, political utility. There's a bit of backlash against this. This is the MOM, the Mars Orbiter mission launched by the Indian Space Research Organization. And the criticism was, why are we sending, this millions of dollars of equipment to study the surface of Mars when there's still people that are in really bad shape, and are in really bad poverty within our own country? And that's in some sense a legitimate concern. Is it is it a false dilemma, or is it a legitimate concern? But you see how science has to sort of proceed carefully, and science has to in some sense show its utility. It's very difficult to justify science for the sake of science. Not many people are going to buy into and fund science just for the sake of science. Science has to have some sort of promise there. There has to be some sort of, some technology or something that is going to be sort of useful in the end. Otherwise, it becomes increasingly difficult to fund science for the sake of science. Another example is that you might graduate as a chemistry student, and you say, well, who am I going to go to work for? A pharmaceutical company, or am I going to go to work for the World Health Organization? And both of them, in some sense, are propose very interesting scientific research projects. There's a infinite number of potential projects that we can direct our scientific energy towards. But the point is, this is a sort of map of the malaria epidemic. And why are we not, let's say, that seems to be a sort of an interesting scientific inquiry that it would also carry with it many beneficial consequences, which is, why don't we find, let's say, a cheaper, more effective treatment for malaria? But you can understand, let's say, from financial incentive, it may not be that appealing or interesting for a pharmaceutical company to develop a cheaper malaria drug, because these are poor countries. Why am I going to develop a cheaper malaria drug when I can develop something like Viagra to sell to people with erectile dysfunction in the first world that have money, when I can sell that pill for $40, as opposed to try to make something cheaper? You know what I mean? So all of these incentive structures basically end up dictating, directly or indirectly, which projects get pursued. So we have to consider that. And now, again, you can think of all sorts of other examples. There's a lot of examples, even, let's say, with regards to the pandemic, vaccine distribution, patents on vaccines, criticism of health officials because what the health officials are saying does not align with some politicians' economic views or their religious views. And so it basically ends up being a mess, see. And now science has to sort of navigate, because of its complexity and because it does require resources, it does require financing. It has to navigate this whole non-scientific world, almost kind of political and economic world. It has to somehow make the case that in doing science, we're going to develop beneficial consequences and technologies. So consider this. Okay, just a few minutes, and then we'll start concluding here. This is, we spoke about this earlier in the semester, the Large Hadron Collider. Most expensive scientific instrument on the planet. Okay, 7.5 billion euros to build. And now there was no foreseeable practical consequences that was going to come out of this level of research. But nonetheless, you have very wealthy nations like France and Switzerland that are willing to basically pay the bill. That we say, okay, there's no foreseeable practical consequence that is going to come out of this scale of research. Now there ended up being sort of indirect consequences. For instance, some people have associated the birth of the internet with this scale of research, because all of these scientists have to have their data, communicated and so on. So it does give rise to very beneficial things, but that's not obvious from the get-go. And the point is, I guess the point I'm trying to make is, you can imagine at one point, let's say CERN comes back to these nations and they say, actually, we found the Higgs boson, but now we have this other theory that we want to verify, and now we need, 20 billion or 30 billion dollars. At one point, somebody's going to say, sorry, I can't. Unless you can show me that there are going to be necessary, direct, beneficial consequences, I can't justify this to you, even politically. I can't justify giving you this money when, let's say, I have, farmers that are suffering from a drought or something like that. Science for the sake of science, say bang boom, but at one point it has to serve something else. It has to serve some sort of practical value. And now we get to sort of a sort of theoretical consequence, which is that you can imagine that we will inevitably reach a practical end of science before we reach the theoretical end of science. That is to say, there will be theoretical questions that we, in theory, can answer, but we cannot practically answer for financial reasons or a constraint on resources and so on. So there are going to be inevitably questions that are open, which can be answered, but which we cannot feasibly
bring ourselves to launching ourselves into that inquest, you know. What else did I want to say? Any other examples? So there are many examples. Keep that in mind. Okay, those three institutions: religious doctrines, political appropriateness, and economic utility. How do these potentially threaten the legitimacy, the nobility, the integrity of science? Okay, any questions with regards to any of that? I just have a few concluding remarks to make for the end of the semester, unless you guys have any questions or concerns.